Assalamualaikum and hello to everyone. In today's video lesson, we will continue with chapter 4 of our syllabus. In this video lesson, we will continue with the next sources for space heat gain in our final subtopic, which are the transmission and internal heat gains. The objective for these subtopics is on the right of the screen. For transmission heat gain, it is calculated in section B of the cooling load estimation table. Transmission heat gain can either be from external or internal sources. For external sources, we must calculate the transmission heat gain through all glasses and external walls which has not been calculated previously. For internal sources, partitions or internal walls for adjoining spaces are calculated here. Ceilings are for space which has another space above it, and heat transmitted through floors are also considered internal source for space heat gain. For infiltration, it can be neglected because we assume that there are no open windows, doors or cracks in the walls. The table shows the summary on how to fill the cooling load estimation table based on the criteria. For glasses, all external glass area should be considered. For heat transfer coefficient, using table 9, refer to the external wall row and choose the value for glass vertical. For wall, external wall which has not been calculated in the solar heat gain section. For partition or internal wall, calculate the heat transfer through adjoining spaces. Using table 9 for heat transfer coefficient, we will refer to the internal wall row and choose the value based on the wall material. Ceilings are for intermediate spaces. In other words, there is another space above the room that we are calculating the space heat gain. Heat will flow down into the calculated space area. For floors, it is simply the floor of the space, and we assume that heat will flow up into the calculated space area. For section C, it is for sensible internal heat gain. Sensible internal heat gain can come from occupants, lightings, electrical and electronic equipments. For occupants, the number is based on the space characteristics. Using table 10, determine the sensible heat factor by choosing the exact or nearest application, or we can even judge by the level of activity in the area. Then under the typical of Malaysia column, we will read the value for sensible heat factor SHF. For lights, the floor area is multiplied by the average occupancy lighting of the space. This is done by referring to table 1 based on the exact or nearest application. Under the occupancy lighting column, read for the average value. For type factor, depending on the type of bulb, it can either be 1 or 1.25. For equipment, fill in the number of equipments available in the space. Make sure to know the rated power for each of the equipment. Next is to calculate the total from section A, B and C. Calculate a safety factor of 10% from the total. Add both the values to calculate for total room sensible heat. Another source for sensible heat gain is from the ventilation of outside air. For CFM, use the highest value for CFM. For bypass factor, usually it depends on the type of system we are going to use. For packaged air conditioning units, the value is 0.1, and for centralized air conditioning units, the value is 0.3. But if we have not decided, we can refer to table 12 and look at the most suitable example and choose the value accordingly. And for section D here, we will calculate the total effective room sensible heat. Now we have come to the end of this video lesson. We will continue with the remaining section for cooling load estimation in the next video lesson. Thank you for your attention and have a good day.